Faisal, let's start with having you share a little bit about the team that you lead at Netflix and how that team came to be. What's your story?
So I joined Netflix about 6 years ago in early 2015. Over the past 6 years, the personalization infrastructure team has grown to touch almost all facets of machine learning and partners really closely with practitioners to enable product innovation.
Who are the constituents that your team serves at Netflix?
Yeah, so that's actually a great question because it's one of the things that is really important to understand your key consumers well. There are essentially what I would characterize as three different sets of ML practitioners that we serve. One is what we internally call as algorithm engineers. And these are people who are trained in both software engineering design principles, but also have a good understanding of machine learning. They are capable of sort of taking a good idea, exploring it, but then also productizing it. Then there are ML researchers who are exploring new cutting edge techniques in terms of how the evolving space can be leveraged for impacting product experiences that we can develop. And then there's data scientists who are oftentimes using some of these similar technologies, but their application is in the context of decision support. So for instance, to make a decision of which content should Netflix invest in. And it's really important for an ML platform developer and teams to really understand the core strengths of those users and sort of play to their strengths. So those are the sort of the three main user sets. I'd say in our org, traditionally, the algorithm engineers have been the biggest user of the infrastructure that we've built, but that's evolving over time and expanding.
You've mentioned the platform several times here, and you provided a slide for us to show a little bit about the platform.
The high level point here is demonstrating the point that I was making about a loosely coupled platform of composable building blocks. Each of these layers is a ML workflow function with training, data preparation, feature engineering, training, model evaluation, inferencing, intent to treat, and treatment. These boxes here show these various building block components that I've talked about. So there's everything from the fact stores to sort of discovery of content and access, the core abstraction that enable the definition of a feature, of transformations, of a model, to higher level ML APIs to do the data preparation and assemble a model, selecting the right features together. There are tools for doing the ad hoc exploration and some things like Polynote, which happens to be an open source solution. You can check it out on polynote.org. And it ties into some of the context that we are operating in. So Polynote, for instance, is a Scala Python notebook, and much of our algo engineers and researchers need to be in this hybrid world of JVM feature encoders, but also using some Python bindings for training and things like that. As you go up higher in the stack here, we're building more differentiated ML services. So things like Hyperplane are about enabling more automation in various elements, hyperparameter tuning, or automating the sort of the deployment of models, so you can run continuous background automation test, scoring service that allows us to decouple the serving with the scoring, so you can throw heterogeneous compute resources, GPUs and others behind when you really need to go after performance, model lifecycle management systems, and then sort of going into the actual services that serve the page is where serving and scoring happens. So there's often a trade-off for a platform developer on where on the spectrum of standardization and flexibility you need to be. We feel that we're at the right point in the spectrum where we can be opinionated, but not be limiting. We have a way in terms of how our platform standardizes key engineering choices around facts and feature definitions and transformations and management, but at the same time gives researchers the flexibility on choosing how models are assembled and put together and which framework that they would use for.
You've spoken a little bit upfront about some of the varied use cases that your group focuses on. One of the areas that you work on is the machine learning infrastructure in support of the media recommendations. Can you talk a little bit about that?
So there's two aspects of what you're talking about, right? One is you have a certain set of assets and you want to figure out essentially which is the best asset that you are going to use for personalizing in a particular context, whether you're coming on a device, a handheld device, or it's on a TV. Are you watching a trailer? Is it part of a gallery page? Is it on sort of the main homepage? And so there's artwork personalization, which I would say is quite similar to the classic recommender system problem, with perhaps one more dimension. The thing that we're beginning to be more excited about is not just the personalization of assets, which so far, let's say, have been selected by editors manually. We're getting into the space of artwork generation or asset generation, where we're using machine learning to enable more productive generation of assets and help editors to find out even more exciting assets and signals within the actual asset files. And so when you're building media ML related infrastructure, some of the things that are different is just the first thing is the dimension of scale is different. We're talking about raw video. You're probably familiar with dealing with some of these uncompressed original master files. And so just, while the inferencing latency is not as important, but access to what signals you can and embeddings you can derive out of these giant files, and accessing these files, discovering these files, and sort of slicing these files, all of those things is a whole new challenge. And
Yeah. Yeah. I was just going to ask, for a lot of platform organizations, the goal is to enable data scientists and researchers, folks that are more on the experimentation side of the spectrum, to get things directly into production through automation. At your scale, is that part of your mandate, or is there this assumption that people are going to throw things over the wall, and engineers are going to take something that's been, a research experiment, and productize it? How do you think about that?
we used to follow that approach, I'd say 5 or 6 years ago, and thankfully we're no longer following that approach, and we've learned from it. No, there's two ways about doing that, right? You could potentially have a very good alignment between your data scientists and engineers, and they can have high coupling. That's doable in small environments, and perhaps maybe not at large scale, but it breaks very quickly as organizations grow, as well as the scale of your problems grow. And so what we have come to doing is like a core set of engineers or algo engineers who understand the dimensions, who both understand machine learning as well as productizing them, sort of hybrid ML engineers, if you will. And they are the ones who are primarily leading all product-facing experimentation. But what we're doing to enable more data scientists to sort of add to that is doing things like where we provide APIs that they can benchmark their research, they can reproduce that research, and they don't have to take it all the way to the production, but they can show enough offline metric wins that justifies doing an A/B test. So that's one approach. The second approach is that where the ML platform can help is investing in a lot of guardrails throughout the production deployment pipelines. So if you can invest in building certain guardrails, not just in the offline pipeline, but also in the serving systems, and then tracking feature importances and model drifts over time, all of those things are just good software engineering principles that enable the system to allow research which may, even if it is, let's say, not fully baked into the engineering goodness, there are checks and balances to prevent that from sort of hurting user experience.
What are some other opportunities that you see ahead, both specific to the use cases that you serve at Netflix, as well as more broadly in the ML ops, ML operationalization community?
Yeah, for us, really, there's several new things that we are investing in, especially when it comes to things like media ML, which is a bit unique to Netflix, but a whole different dimension. As I mentioned, this is about the creative asset generation opportunity, and it can be huge given the amount of investment and that we are putting into original content. And this is really a new space for us. So investing in identifying the right abstractions that will be relevant for infrastructure support of media ML is a big one. The other is leveraging automation more and across the ML stack. We're certainly using parts of automation in various cases, but embracing auto ML functions more for picking what can be sometimes tedious parts of a researcher's timelines, for instance, picking out, selecting the right features or identifying the right neural architectures. That's an area where we intend to invest more in. And then also in the automation of how the this research is actually taken to production and what I call member-facing continuous A/B testing and explore exploit systems, because then you can do things which are probably not justifiable for a researcher's time, but if they are running in the background with the proper guardrails, then you really can do a lot more, and something in the background can keep on identifying small metric wins, which can accumulate into a big win. So that's an opportunity. And then third, I would say providing more turnkey systems for various ML techniques. So for instance, in Netflix, we use multi-armed bandits and contextual bandits quite a bit, which is an approach to quickly learn an optimal state and start sort of leveraging the winning solutions faster than our typical A/B tests would do. And there's been 2 or 3 different ways in which they have been implemented. This is an example of something I mentioned where, hey, we don't know whether we're going to be investing a lot into it. So we said, okay, let's go ahead and build it in one way. And now there are 3 teams that are doing it in 3 different ways. And here's an opportunity for us to sort of say, okay, you know what, we can standardize here and we can build a turnkey system. So that to me is another area where we plan to invest. And then you can never over invest in your guardrails and how you make sure that because it sort of enables a lot more confidence in how quickly you can take your research to production.